Welcome back to our channel ClassFly community. So today is the lecture 7, that is the cantilever, and today we will learn about the expression of Young modulus in a cantilever. And here as we are doing the expressions, so we will go step by step. Okay, so without wasting more time, let's begin. So expression of Young modulus in a cantilever. So first of all, what we will do, we will know what is a cantilever. So a cantilever is a beam fixed at one end and loaded at the other end. So it is a cantilever where one of the side will be loaded with something. That means loaded with any load or any weight, and another end will be free. Okay. Next, we need to consider a load W. So this is the load W, which is applied to the free end of length L. So this is the length L, and here it is the N which is being loaded. Okay. Let O be the deflection of the free end of the cantilever under the load. So this is the deflection which will be under the load, and this deflection will be maximum at the free end and is equal to 0 at the fixed end. So here it will be equal to 0 and it will be maximum at the free end. Okay. Now we will assume let PQ equal to dx. So PQ will be a small section for this A and B, that is the cantilever. So this will be equal to dx, and this is the small section of the neural axis AB. Now PQ is at a distance x from the fixed end. So as this is the fixed end, so it is at a distance of x from the fixed end. Now the next point is that the radius of curvature of neural axis. So this is a neural axis and its radius of curvature is r. And the deflection of PQ. So this deflection of PQ will be represented with dy. Now we will move on and see the expressions. So the radius of curvature of the neural axis is given by the equation, that is, it is 1 by r equal to d square y by dx square divided by 1 plus dy by dx to the power 3 by 2, whole to the power 3 by 2. So when you will solve this, you will get d square y by dx square, which will be our equation 1. So you need to remember that the radius of curvature of the neural axis is equal to 1 by r equal to d square y by dx square. Now you need to know that dy by dx is very small and the higher power can be neglected. Now the moment of applied force acting on this PQ will be equal to W L minus X, and the restoring couple due to the elasticity of the beam will be Y Ig by R. So Y is the Young modulus, R is the radius, right? This will be our equation 3. At equilibrium, these two are equal and opposite. That means this one and this one will be equal and opposite. So see, as we know that 1 by r is equal to d square y by dx square, what we will do, in place of this 1 by r, we will write yig dot d square y by dx square equal to this one, that is the moment of applied force, which is W L minus X. Now this will be our equation 4. So now what we will do, we will integrate on both sides. So y and ig are constant, so it will be moved out. Similarly in this side, the w is constant, so it will go out. So we will integrate d square y by dx square with dx, and L minus x will be integrated in the other side. Now let's move on and see what happens after the integration. So on integration we obtain Yig dy by dx equal to w bracket Lx minus x square by 2 plus c, and we know that where c is the constant of integration. So you all know how to do integration, so you can simply do that simple integration and you will get this required answer. Now what we will do, we know that the deflection is 0 at x equal to 0 and dy by dx is equal to 0, which implies that c is equal to 0. Therefore, we will integrate from 0 to delta. Okay. Now, we will integrate from 0 to delta and this dx goes here, this side. Now, what happens? When we integrate this, we get only delta. And when we integrate all of this, we get w L to the power cube by 3. From this equation, what we get? We get our delta equal to w L cube by 3y is the Young's modulus and Ig, which is our equation 5. So, you need to remember that for a rectangular cross section, that is your Ig is equal to BD cube by 12. Okay. And now what happens when we replace this Ig by this one? So what we get? Y BD cube, right? And this 12 goes up. So we know that when we divide 12 by 3, we get 4. So from that we get delta is equal to 4WL cube by YBD cube. Here the BD cube is, B is the breadth and D is the thickness. Okay. Now see what happens. Now we can determine the Young modulus of a cantilever because y is a Young modulus. So we will take this y this side and bring this delta down. So we get an expression that is y is equal to 4 mg L cube by BD cube and delta. So mg is the mass, that weight. So mg, where that is under a load. So you can say that what happens here, that this L is the length, B is the breadth, D is the thickness under this load, that is mg. So whenever there is a weight, we represent it as mg. Okay. So this will be your equation, that is the Young's modulus expression in a cantilever. So I hope all of you understood, and I have done everything with points, with expressions, so it will be easier for you to note down, and if you write all of this, I assure you, you will get your full marks. So thank you for watching. If you have any queries, please comment us down below. We will follow you up there. Till then, be happy and have a great day, and again thank you for watching.
Wow, that's impressive. You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.